some of these complex interactions of insects and pathogens and fire. And I'll go over for you some of the comedy of the drama of what goes on, and I'll try to end up with some things that you might do to in your own situations if you have fire-damaged trees to try and control those interactions. I'm going to start out with the insects, with the wood-boring beetles, and the wood borers are the first ones to come in. They're not tree killers, but they make their living on dying and recently dead trees. Starting with the wood borers and then going on to the bark beetles. The bark beetles, many of them are perfectly happy to come in and breed in dead and dying trees, but they can also be tree killers. And so we have kind of a different interest in what the bark beetles are going to do. I'll go over the dwarf mistletoes. Dwarf mistletoes have a very strong interaction with fire. And I'll be talking back to some of the things that Paul Hesberg said last week. The fungi have some, not as much interaction with fire as some of these other factors, but they do have some of which are sort of comical. And then at the end, I think I'll have time to go over those factors that affect survival of fire-damaged trees. Can you see, or should I get up?
No, I'm fine.
Okay. So I'll try to go over those factors that affect fire-damaged trees and some of the ways that you can evaluate your own trees. Are any of you dealing with fire-damaged trees on your property? I'm trying to. Okay, yeah, some people are. All right. Okay, I'm going to start with a group of wood borers that are referred to as pyrophilous insects. And these are insects that are positively attracted to fires and to heat and to smoke. This photograph was posted by a firefighter in California who was participating in a controlled burn. And he described these wood-boring beetles. These are Melanophila beetles, sometimes called fire beetles, that came in and just covered him and his co-workers. Now, some of you, I'm sure, are or have been wildland firefighters. Yes? Yes? So you've seen these pyrophilous insects, and no doubt you know at least their common names. So there are the fire beetles. There are the horn-tailed wasps. These are also wood-boring insects, and they're kind of alarming to firefighters. They're large. They have long ovipositors that look like stingers. And I know one thing that has happened to me is, I'll be out on the fire line often as a resource advisor, and people will ask me what my regular job is, and when I tell them, they'll look at me and they'll go, well, what are those stump humpers anyway? And that's what they are. They're horn-tailed wasps. And then, if you've ever been doing mop-up after a wildland fire, you know that one of the ways you can find hot spots is by looking for these swarms of little tiny flies, little gnats. Sometimes they're called smoke flies. And if you take off your glove and put it there over where those insects are congregating, you'll find that it can be very hot there, up to 300 degrees. And they'll actually come in and they're attracted to that. So, I have, if you did your pre-work reading, you probably saw some of these pictures. So this is one of the Melanophila beetles. This is called the charcoal beetle, Melanophila consputa. And that photograph on the right, that red arrow, is actually showing you where the infrared organ is that helps this insect to orient toward fires. There was an entomologist in the 1940s by the name of Lindsley who wrote about a situation that would occur during University of California football games. Now remember, this was in the 1940s. You'd have this open-air stadium, and you'd have 20,000 cigarettes being lit up at the same time. And these beetles would come into the stadium and land on the spectators and bite them. They've been known to respond to industrial areas where, say, metal was being processed. They're very, very attracted to heat. This electron micrograph in the center there, that shows the organ, and around these individual organs are wax pockets. So the beetle is constantly excreting wax around these organs, and they're actually all over the beetle's body. At the base of every setae, which are the hairs on the insect's body, are these wax glands, and they're constantly being excreted, evidently to keep the beetle from drying out because of its very strong attraction to fire. Now, when the beetles come into fire, they're not looking for food for themselves. These adult beetles are looking for a place where they can mate and where the female can lay her eggs. So what they're looking for is food for the babies. The female will lay her eggs in the bark crevices of these dying and recently dead trees. These eggs hatch very quickly, in just a few days, and the grub-like larva, which has very powerful jaws, will chew through the bark and down into the phloem, which is that nutritious layer just underneath the bark, where the nutrients are translocated from the needles down to the roots. So there's a lot of nutrition there. And these larvae will dig around in that phloem until it's gone or it's dried, and then they'll actually bore down into the wood. And they can use that wood as a food source, and it'll take about a year for them to complete their life cycle, and then they pupate, go through that magical transformation from the grub to the adult insect, and then the adult beetle will dig itself an emergence hole, come out, and the process will start over again. So all of this happens, in the case of Melanophila beetles, even before the fire has completely gone through. So if you are wanting to salvage your logs, you're going to get damage from these larvae within days or weeks of the time that the fire burns. So that would be a reason, if you want to get those logs out, to get them out pretty quickly to get the maximum value. And it's also a reason, if you are handling raw logs from fire salvage, to be a little bit careful. This is one way that insects get spread, because these wood-boring beetles can survive in dry logs. Some of them can even survive in lumber. So, and there is one of these borers that has a common name of the new house borer, because it can survive not in kiln-dried lumber, but in air-dried lumber it can survive, and occasionally will come out in your new house. So that's another reason to kiln-dry your lumber. Okay, so the wood wasp, again, she's not looking for food for herself, but she's looking for a place to lay her eggs. Unlike the wood-boring beetles, she does not lay her eggs on the surface of the wood. She has a long ovipositor, an inch or more long, and she's going to jam that thing down literally into the wood, and lay her eggs in the wood, and the larva spends its entire life in the wood. It doesn't bore in the phloem at all. And that's how she gets her common name. And this takes a lot of energy out of the insect, jamming that ovipositor down into the wood. And sometimes they'll actually get stuck in there and die. And I took this photo, not on a fire. This was actually on a landslide, where a bunch of these wood wasps had come in. This is out of War Creek, John, that landslide in War Creek. So there were a bunch of dead Douglas firs there, and the wood wasps came in, and this poor lady just got stuck in there, and she was hanging there dead when I found her. But these larvae also can cause a fair amount of damage in wood products if they get going. Now these are the smoke flies. I just included this photograph. I found it. There's a researcher in Moscow who's doing some research on these flies. They are not well researched, And I imagine the reason is that they don't damage wood products and they don't affect human health. They're there, we don't see them very often, but down here at the lower left you can see a mass of eggs that this fly has laid. So evidently what they're doing when they congregate the way they do is they're mating there, and then the female will lay her eggs on damaged plant material, on brush, on limbs, and the eggs hatch and the larvae find that as a food source. So there are other wood-borne beetles that are not specifically attracted to heat and smoke, but they come in very quickly after the fire. And so that picture on the right, this tree is recently dead. This is the Pot-Peak fire. And you can tell that this tree has been infested with wood-boring beetles. It's rather covered with this orange boring frass, which the beetles, not the beetles, but the larvae of the beetles kick out as they're feeding there inside the phloem. There are two major families of wood-boring beetles that we have, and the common names are the round-headed borers, also known as longhorn borers. And so that's the upper photograph. Their heads aren't totally round. They have a flat plate on the upper side of their heads. The flat-headed borers have flat plates on both sides of their heads and look rather more like a horseshoe nail. They make somewhat different galleries. So on the upper right, that's the gallery of the round-headed borer. It's a fine frass with markings in it that kind of look like a series of fingerprints. The flat-headed borer shreds the wood. And is anybody old enough to remember Excelsior? I remember that's that wood packing material that we used before plastic peanuts. And I remember as a child getting packages from my dad in Europe that were packed in this Excelsior. It wasn't wood borer frass, but it rather looked like that. So here are some of the adults, the longhorn beetles. These are a couple of pine borers on the top. The short-horned borers are also known sometimes as metallic borers, and because some of them are really very beautiful. And that one on the left, this is the golden buprested, I think is one of the prettiest things in the woods. Does lots and lots of damage to wood products, but they have great value in the woods if you're going to leave that material out there, because of course they start that breakdown process. Now the bark beetles. The bark beetles, unlike the wood borers, both the adults and the larvae, in fact all the life stages take place under the bark. They don't all respond to fires. They can be tree killers. They can come in and build up populations in dying trees and then sometimes attack other trees that might have survived their injuries. So there's always a concern about what's going to happen with the bark beetles after fire. And this one is really complex. It depends very much on the time that the fire occurred, because for the bark beetles to respond to the fire, they have to be flying. And if the fire happens outside of their flight period, which is limited, they won't be able to take advantage, at least not in the current year. And then also the weather after the fire will make a difference to them. So the major bark beetles that we know respond to fires are the Douglas fir beetle, which attacks Douglas fir, and then three of our pine beetles. The western pine beetle, which is only in ponderosa pine, the red turpentine beetle, which can get in several pines, and then the pine engravers, which can also get in several different species of pines. So the Douglas fir beetle. This one is active from early May through mid-July. So the Carlton complex fire burned in mid-July and on into late July. There's wasn't much opportunity for Douglas fir beetles to take advantage of the fire this year. Some of the trees that they might have colonized will be eaten up by wood borers. But there will be damaged trees that are still relatively healthy, not attacked by wood borers, that may be attractive to Douglas fir beetles next year, particularly if there's a pretty good Douglas fir beetle population in the area already, as we know is the case, for instance, in the South Summit. It's also already a fairly high population of Douglas fir beetles. So what we have there at the top right is the happy couple. They've just gotten into, in this case, a blowdown. And so they're mating in there, and the female is starting to lay eggs on either side of her gallery. And then on the lower right, that's what the final gallery looks like. The adult makes that vertical gallery, and then the female, she lays her eggs on either side, and the larvae, the immatures, they start eating on either side of the adult gallery, and you get this sort of beautiful fan-shaped pattern when it's all over. The western pine beetle. This one is active for a longer season because this one has 2 generations a year. Douglas fir beetle just 1, but the western pine beetle has 2. So the first beetles will fly in early June. And then there's another, and then they complete their life cycle. They actually go all the way from egg to larva to pupa to adult. And then you'll get another generation of western pine beetles that will fly in late August. So these could have attacked some trees after the Carlton complex. Trees that perhaps were not killed, or that were killed but not so scorched that they still had good phloem that the beetles could make a living in. So beetles that attacked in late August would right now, as we speak, be in the larval stage. So they'll be large larvae. They'll be in a state of hibernation right now. They become active again as the weather starts to warm, and they'll develop into these callow adults. So on the right there's a pale-looking beetle, and this is a soft beetle that has just come out of its pupal stage. They'll feed some more in there. And then you'll get the mature adult, which is on the right-hand side, which is a hardened black beetle, and they'll fly again in early June. So if you look at this picture of the callow adult, you'll notice on her right, there's a gallery of a longhorn borer. So there's competition. There's competition between the wood borers and the bark beetles for this resource of these recently damaged trees. And the wood borers can outcompete the bark beetles because sometimes they'll get there earlier. And if the larvae of the wood borer encounter the larvae of the bark beetle, they'll eat them. So there's some beetle cannibalism that'll go on there. So it really is pretty complicated. Pine engravers are not terribly aggressive for us, but they can do some damage. Pine engravers are active for a lot of the season. They'll get started pretty early, in early May. They'll be active through August. They're a small beetle. They have 2 generations a year at least. As we start to have longer summers, there's always the possibility they could go through a 3rd generation, but we're not seeing them do that now. These are absolutely ubiquitous in pine slash. If you have road construction, logging, thinning, and there's pine slash on the ground, they'll get in it. That's their preferred habitat. And recently dead trees from fires, they like to get in there. They don't like really large diameter material. Things that are 5 to 7 inches in diameter is where they prefer to be. And when we get problems with pine engravers, such as that situation on the right, so what happened there was we had a pile of pine slash next to this group of small diameter live pine trees. The pine engravers built up a pretty big population, and then there was no more slash for them to get into, so they just went into the nearest thing, and they killed this patch of young pines. If they do this kind of thing, it doesn't last for more than a year, but this is something that we could see. They'll get into small trees, they'll get into the tops of damaged trees, anything that's down to about 5 inches in diameter. Red turpentine beetles. Now, many of our tree-killing beetles are in this genus, Dendroctonus, and Dendroctonus means tree killer. The Douglas fir beetles and the western pine beetles are in this genus too, Dendroctonus. But red turpentine beetles are not a tree killer, not for us. And the reason that they're not is because, unlike our other bark beetles, they don't really make a gallery. The adults, they feed in just one area of the tree. They lay their eggs in a clump, and the larvae feed in that clump, as you can see on that picture on the right. And the pines, our native pines, react with this terrific pitching, and the beetles have adapted to this pitch. They can tolerate it. They sometimes get pitched out, but very often they can just keep on feeding in there. They attack at the base of the tree, sometimes down into the roots. Rarely do you see the attacks more than about 4 feet above the ground. And it's really characteristic that you see these tremendously big pitch pockets, and you can recognize red turpentine beetle that way. They have a fairly short active period, from late April to early June. So I have not seen yet any red turpentine beetles, but they are known to be particularly attracted to fire-damaged trees. They're also pretty common in campgrounds, trees that have been affected by soil compaction. They don't kill trees, but they do weaken trees, and so they can add to the overall damage that's been done to the tree. Very commonly, they'll attack a tree that's been attacked by other tree-killing bark beetles. But this beetle has potential. And we know that because China imported raw logs from the Pacific Northwest that had red turpentine beetles in them. And they are a very aggressive tree killer in China. Chinese pines have not any resistance to red turpentine beetles. They go down into the roots and they kill them. And it's really sort of heartbreaking to see. It's kind of like what our mountain pine beetles have done. Red turpentine beetle has done to Chinese pines. So if you want new research on red turpentine beetles, you read the Chinese literature, because they're the ones who are really researching this beetle. Now, bark beetle control options. They have to be prevention. An infested tree is a dead tree, with the exception of red turpentine beetles. So the things that can be done is you can remove the very attractive damaged trees. And at the end, I'm going to go over the rating system that we've been using with pretty good success to try and evaluate the risk of the different species of trees being attacked by their respective beetles. You can remove the currently infested trees. This is very difficult to do. And it's difficult to do because it's difficult to keep track of them, and timeliness is everything. You need to see when the beetles have attacked the tree and remove that tree before the beetles fly. Once the tree is visibly dead, the needles have turned red, by then the beetles have come and gone. It takes a tree often a year to turn color after it's been attacked by beetles. You picture cutting a Christmas tree. The needles don't turn brown right away. And the same with what bark beetles do. So it's difficult to do, but for individual trees, say in a yard, you might be able to do it. Insecticidal spray will work, and I have a little literature on that if people are interested. Again, it has to be done before the beetles attack, and the tree has to be sprayed from top to bottom. So if it's a large tree, you're going to need equipment, and you're probably going to need an operator. It can be done for individual high-value trees, household trees. Sometimes it's done for campground trees if there's a high-risk situation. And then for Douglas fir beetles only, we have an anti-aggregation pheromone. And this has been such a cool development in entomology. So Douglas fir beetles, when they have fully colonized a tree, they produce a pheromone that tells other Douglas fir beetles to stay away. The tree is full. And that pheromone has been produced in the laboratory, and it is so effective, keeping Douglas fir beetles from attacking at-risk trees. It's produced in this form. So these are called bubble caps. Each of these bubble caps contains 4 milligrams of the liquid pheromone. The short name is MCH. And these can be stapled to trees or stapled around trees. And it really works very well if it's applied timely, which would be in the spring, just before the beetles start to fly. Now moving on to the dwarf mistletoes. You remember last week when Paul Hesberg was talking about the changes in the fire regimes in our landscapes and how we had less fire. Dwarf mistletoes really have a very close association with fire. Dwarf mistletoes are native plants. They are parasitic plants. They don't photosynthesize. They are completely dependent on a host tree. They put down a root into the host tree, and they get all of their nutrients by parasitizing the host. They cause abnormal growth in the host, and one of the things that they cause is this really heavy branching that will often be right down to the ground, and lots and lots of it. So this affects fire behavior because it brings fuel down to the ground, and it'll present ladder fuel that will then carry fire right up into the crowns of the tree. People who model fire behavior will add dwarf mistletoe into the mix when they're calculating what fire behavior is likely to happen. And obviously it affects the survival of fire-damaged trees. We have 4 dwarf mistletoes. I only have pictures of 3 of them, but each dwarf mistletoe is specific to a host. So we have a western dwarf mistletoe that affects ponderosa pine. We have a lodgepole pine dwarf mistletoe in lodgepole pine. We also have a larch dwarf mistletoe in western larch. And then we have the Douglas fir dwarf mistletoe. Now, of all of these dwarf mistletoe plants, the Douglas fir dwarf mistletoe plant is by far the tiniest. It's very hard to see. The mature plants are really no bigger than the needles of the dwarf mistletoe itself. But of all these dwarf mistletoes, it really has the most devastating effect on its host. So these are Douglas firs affected with Douglas fir dwarf mistletoe. The dwarf mistletoe brooms, these are called witch's brooms, this abnormal growth. And they will often in the winter fill up with snow and ice, and they get terrifically heavy. They'll weigh hundreds of pounds. And often they'll fall off the tree. They create lots of fuel on the ground. So 2 things can happen when fire burns in a dwarf mistletoe infected stand. And one is it can kill the tree. Dwarf mistletoe brings fire into the crown. It also just generally weakens the tree. So even if it doesn't burn up into the crown, the tree is much less able to recover from its injuries. But if the tree does survive the fire and the dwarf mistletoe plant is killed, dwarf mistletoe is an obligate parasite. So if a branch is killed or if a host tree is killed, the plant is dead. And so fire can actually cleanse dwarf mistletoe from a tree or cleanse dwarf mistletoe from a forest stand. So we know that we now have a lot more dwarf mistletoe in the forest than we had 100 years ago because we don't have fire as much cleansing our forests of dwarf mistletoe. And while dwarf mistletoe can infect a large tree and that tree can live for a long time, if that dwarf mistletoe then gets into seedling Douglas firs, that seedling will never reach mature size. It becomes what we refer to as Douglas fir cabbage. And it will just become a little ball of dwarf mistletoe.